and welcome to this first ever live Awesome Astronomy show, nestled uncomfortably close to the April Part 2 show, which you will have downloaded yesterday and no doubt heard already. But thanks for joining us in what's inevitably going to be less professional than the recorded shows, but hopefully we can make it more fun by getting everybody involved, not least our special friends, University of Oxford Professor of Astrophysics and Citizen Science lead Chris Lintott, Senior Astronomer and Institute Fellow at the SETI Institute, that's the Search for Extraterrestrial Intelligence, Seth Shoshtak, the Director of Public Engagement for Cardiff University's Gravity Exploration Institute, Chris North, and since it's not just the 50th anniversary of Apollo 13, but the imperiled Apollo 13 crew were actually limping back to Earth at this exact time 50 years ago, we'll be speaking to US spaceflight researcher and chronicler Gavin Price later in the show. And before we kick off proper, I just want to say that we've had lots of requests to do an episode dedicated to answering listeners' space and astronomy questions. And producer John thought this would be the perfect time to do it when people are cooped up and struggling with isolation. Then we thought, well, why not increase the stress on us by making it live with software we've barely tested? And here we are speaking to dozens, hundreds, thousands, or maybe just ourselves. But by doing it this way, rather than just a recorded release, it means we can all come together virtually. You can all get involved in real time by sending in your comments or questions for us, or our guests by Twitter at AwesomeAstropod, by email at theshow@awesomeastronomy.com, or by Zoom chat if you're using Zoom. And most of all, we can hopefully provide 90 minutes of respite from the pressures, the tedium, or the horror of this current pandemic. My name's Rolf, loosely hosting this show, and joining me as always are the ever erudite Jen. What a pop-up there.
I know, right? What an entrance.
And the seasonally scholastic Paul.
Hello!
Hey!
I say, well, isn't this a merry broadcast? Jin.
Come in, London. Can we have your Eurovision votes, please?
Luxembourg 3, Belgium 4.
Oh, I've gone back in time.
Yeah, you're in Australia. Or is that Newcastle?
I am.
Newcastle.
Have I been to Newcastle, though?
So on with the show, and before we welcome Chris Lintott, we've just got time to delve into the question we're most frequently asked, and that's what astronomy equipment do we use? So keep it brief, people. What equipment do we use? Do you want to go first, Paul?
Mostly at the moment, a 10-inch dog. That's my poison with some pencils, bit of paper, and a bunch of star maps, which I was doing last night. Hopping around.
You are doing a lot of sketching at the minute. I'm really
the sky's been brilliant. It's been clear ever since lockdown. It's been an astronomy fest. It's been fantastic. Yeah, and I've been running online astronomy star parties for various groups. It's been brilliant. It's great streaming from the telescope. It's been fun.
Are you actually streaming from the telescope?
Yeah. Camera in the scope, streaming, brilliant. All over Zoom.
That sounds fantastic.
Oh, it's great. It's great. No, and I don't have to go anywhere. I can do it from my garden.
That's brilliant.
I just have to drive miles to do these things. It's brilliant.
This is the future, right?
It is. I'm never going to leave house. I can do it all from here. Jenny, what do you use?
I use my eyes at the minute, if I'm being honest. The problem is, right, I don't live in a great area, so I don't really want to have very expensive astronomy equipment in my house because I don't trust the people around me. So all our nice telescopes. So I've got a Celestial 925. I've got a Coronado Sonamax 260. I've got a William Optics. So I've got a few different telescopes. Depends on what I'm doing. They're all back home with parents because they're nice and I don't want anything happening to them. I do have a small refractor. I can't even remember what make it is. It's sat on my desk. I'm looking at it now. It's wrapped up in bubble wrap, which I actually took to, guess where? Australia. So I've got that one with me and do you know what? I should do more often.
You should.
So I have that with me in Cardiff, and a couple of little eyepieces and stuff. But to be honest, I've just been going outside and just having a look at the sky, watching the ISS go over, being like, oh, look at that, there's the moon.
Yeah, I've had the we could see the message here from Matthew Hodgson, who's watching us, saying mirrors are for shaving, refractors all the way, and that's something we hear quite a bit, isn't it, in that debate between refractors and reflectors.
And no, Dustin, not the Dead Poets Society.
Yeah, so mine is I've got like a skin down kit that I just use all the time, which is basically a 115 refractor, a triplet, just for that nice contrast and a good quality scope rather than going for lots of different scopes. And then I've got a small
with a refractor.
And a refractor, yes.
Yeah, with a refractor, you can see all the space vampires. You can't see them with mirrors.
Exactly. You can see them coming. Yeah.
Brilliant.
But I've not been able to get the scope out because I'm feeling a little bit weak at the moment. Come down as I have with coronavirus, would you believe? So,
yes. I know.
I guess I guess statistically 1 in 5 of us was going to come down with it, and then
you are the person.
Yeah. So even if I'm off my tits on drugs at the moment, so even if you're not enjoying yourselves, listener, I am. I'm having a great time.
I'm locked in a house with 2 small children, so I wish I was off my tits on drugs.
So one of the questions that I wanted to ask, I don't know whether this is delving into the world of conspiracy theory or not, so I'm interested in your guys' take on this. We've had some fantastic skies ever since the lockdown, and the fact that there's been no planes in the sky and the pollution's all been dropping. Is that the reason why the skies have been so good recently, or is that just coincidental?
It's been some interesting discussions about this.
Yeah.
The idea that aircraft aren't at altitude, sort of putting particulate into the air and turbulence. It's interesting. I wonder if it's that we think, that we're bigger and more important than we are, and therefore, we see a 747 as a massive thing that's going to tear up the sky. But I'm not convinced. Though the skies have been extraordinarily clear, I think it's just coincidence.
Because I was just wondering whether, like, the kind of dirty water vapor that comes out the back of jets was acting like seeds and maybe helped clouds to form and the like. And certainly, if there's going to be more pollution in the sky, then that would be the case too, wouldn't it? That you've got particulates in the sky that acts as a seed that clouds can form around, or certainly water droplets can form around.
I mean, this is the thing, 'cause it's not just airplanes, right? It's like all transport is so much lower. I have had this thought myself, and I still don't know what the answer is. I'm assuming that people are doing some work into it. I know that like when volcanoes and stuff have gone off, that does have an impact on like local climate in terms of clouds and things like that. So I'm like, is it an extension of that, or like I say, is it just wishful thinking and us pretending like we really matter, we're really important and stuff?
Dustin, atmospheric pareidolia.
Are you going to explain what pareidolia is then, Paul?
Good praise. No, I'm not.
Pareidolia is when you see shapes, isn't it? Like you see faces in clouds and things like that. We've also got Dave Woodford, who's saying it's still cloudy up north, guys. So maybe this is just a north-south divide. And
and we've had. I mean, it's actually clouding up now. I'm looking out my window, and literally, it's clouding up as I speak. If I'll move my camera. Look, I don't know if you can see it, but it is literally clouding up as we speak.
There we go.
That's it. Because we've talked about it, we've cursed ourselves.
And it's going to be the first cloudy night here for days and days and days. First cloudy night we've had for a very long time.
And to be honest, I feel weird with all the sunshine, especially like South Wales. It's always cloudy. It's always raining. Like, what's that thing in the sky? I don't understand. The cat's been confused. She'd be screaming at me, going like, I don't understand. Take it away.
Well, let's move on to our first guest now. I'm delighted to welcome onto the show the University of Oxford Professor of Astrophysics and Citizen Science Lead, Chris Lintott. How's lockdown treating you, Chris?
Well, I'm pretty lucky. I am. Yeah, this is the London flag in Oxford. I've resorted to virtual visits to the pub, which is the main problem for me. But no, things are fine. We've got our students and our team working from home. So I just have a shorter commute, really. It's not the same for everyone. But I was just listening to you talking about the skies. Isn't it a blessing that it's been clear?
It's been wonderful.
The saving grace has been seeing the ISS and watching Venus and watching people discover our great subject as
Yeah.
well. We're used to going outside and looking up when you leave a pub, but watching other people discover that that's Venus and that you can see it the next night and that it changes and so on has been, I think, the thing that's kept me going.
It's like things have flipped around. Rather than us trying to encourage people to look out into the sky, almost on a daily basis, people have been getting in touch with us via Twitter and saying, "What's this that I'm seeing in the sky?" And people
that's right.
reaching out to learn.
Although I did enjoy an email I got from somebody who said that they'd seen the bright thing in the sky. They'd asked somebody what it was. They were told it was Venus, but they weren't satisfied with that answer and would like a different explanation. But sorry, it was still Venus. So, but also things like people have been noticing people were out. We had that wonderful run of space station passes here in the UK, which lasted the first couple of weeks that people were at home and people were out seeing the station, which was good. But then noticing other satellites, and I think a lot of people who don't know the sky well was surprised as to how easy it is to see satellites. You go outside within a few hours after dusk, you wait. You're much more likely to see a satellite than a meteor these days. And I
and
think
if anyone's got anything, I was going to say, if anyone's got anything at the minute, it's time, right? To just sit there and look.
Yeah, I think there's also the people who are rushed off their feet. So I'm getting two kinds of. I'm getting people with the time to enjoy and learn and think, and we see those people in our citizen science project. There are also people, I think, stopping halfway up the stairs to look out the window and just have a moment to themselves. So people who don't have time could. I'm a great fan of lazy astronomy. I think I'm used to long nights with a telescope and trying to see detail on Jupiter or Orion Nebula with the naked eye, with the eye, or whatever else. But there's something wonderful about, oh yeah, there's the moon, I'll see that again tomorrow. I think that sort of straightforward everyday astronomy is getting a lot of people through these very strange weeks that we're living through.
Yeah. Well, being the zookeeper of citizen science, Chris, I wanted to ask you a question from one of our listeners that came in that was perfect for you, really. Your latest books actually states, with more data, you need more scientists. So that leads us nicely into a question from David Schlaut via Twitter, who asks, are there ways for an amateur astrophotographer to get involved in contributing to actual science? And I think it'd be really interesting to hear both from the viewpoint of what an amateur astrophotographer can do to get involved in contributing to proper science, but also what anybody else can do from their armchair.
Yeah, of course. Well, it's an interesting thing. I think as long as I've been interested in astronomy, people have been forecasting the death of the amateur scientists. So people have always said that the next generation of professional sky surveys will knock out any space that amateurs can contribute. And it hasn't happened, and it's not going to happen, because the sky is big and there are things that you can only do with a distributed network of small telescopes. So I think the things that are really alive right now are the planetary photographers. So we rely on amateur astronomers to tell us about Jupiter and Saturn and what's happening, to the extent that NASA's Juno mission, which is in orbit around Jupiter, does these swoops very close to the poles of Jupiter, relies on amateurs for the images that give the probe data its context.
Oh, right. And
there's been close collaboration. So if you're getting into astrophotography and your aim is to take part in science, I think planetary photography is your thing. There are also deep sky photographers that contribute, particularly looking at very faint structures, the kind of thing where these dedicated people go out and build up 200 or 300 or 400 hours worth of data on a single field so that you can get a very deep image. That's hugely helpful, and professionals need that information and haven't really got the hang of doing it ourselves. The amateur images tend to be better. So there are ways for astrophotographers to contribute. If you don't have a camera, you're not that technical, meteor counting is still useful. So I still go and count meteor showers, because that's how I can contribute as a back garden astronomer with a drink and a deck chair. It's the easiest form of observing. And then my own work during the day is to run the Zooniverse platform, which has 98 live projects online today, not all astronomical, but where people could look. 98. So people could look for planets, people can help explore the Martian poles, You can classify galaxies, and there's loads of astronomy there. So that's your cloudy night altar. If it's clear, put the computer down and go outside or look out the window. If it's possible, if it's cloudy, then you can go to the computer and still do something in 5 minutes that's useful to help us understand the universe.
Yeah.
I hope you didn't want short answers.
No, we've got
Yes,
plenty of
people
time to
can
fill.
contribute. Yeah. So this is what happens when I'm in a pub. You get the long, loquacious answers.
It's when there's no queues at the bar, isn't it? Yeah. It gets you itchy
Yeah,
to
though
get to the bar.
you can't quite see. I was on a telecon with this background, a wider version of it earlier, and one of my students messaged me and was worried that the two people in the back corner haven't moved in an hour. So.
In the prod, see if they're okay. Where does people like Terry Lovejoy sit, who are kind of on that boundary of amateur and professional, and you know they're out finding comets and things like that?
Yeah, and of course Comet Borisov, which was the first big interstellar comet that came through the solar system. That was an amateur discovery.
Yeah.
So I think we in the professional world, we started to call these people citizen scientists.
Yeah.
I'm not hugely in love with the term. It's sort of weirdly loaded. Like, what does it mean to be a citizen? What does it mean to be a scientist? But to get away from this sense that there's professional and then there's amateur.
Yeah.
Like we're all, even the professional. I'm lucky enough to be paid for it, but I'm exploring the universe because it's what I've always wanted to do. So I think we just get rid of those boundaries. And there are certainly people with the kit to rival the professionals. I've been thinking about this a lot recently because a lot of the big telescopes are shut down. And while we've still got things like the automatic scopes that scan for near-Earth asteroids, if we, if something dramatic happened, if a big supernova went off tomorrow, we're going to be reliant on amateur images to give us the context, at least in the build-up. So this may be the worst time for a supernova to go off, but it would be fun trying to coordinate everyone's observations.
Yeah. So did Paul spot one first the other night, or did that not come to pass?
No, but it's a good example. Paul on Twitter. Will you tell the story, Paul?
Oh, I was looking. When was it? 2 nights ago. I was looking at various galaxies in Canada's Lintott, and it was M63, and it was just what looked like a very, very curious, one of those tiny sort of spots of light. I've seen supernovas in a couple of galaxies in the past where people have found them, and you get that very, very tiny dot in a visual telescope. It was M63, and I kept going back to it. I kept checking it wasn't just, it was something there, but I mean, probably just my aging eyes and weird seeing and things like that. But I thought I'd sort of mention it on Twitter and see if anyone had noticed, and Chris picked it up.
Yeah, and I know the people we work with. One of the things we do in the Zooniverse is help to hunt for supernovae. So I talked to my friends at Queen's University Belfast and in Minnesota, and they found out the Atlas telescope, which discovered Comet Atlas, had looked at M63 just a few hours before we asked. So we got the data and no supernova. But it turned out that group are haunted by, I think in 2014, somewhere around then, there was a supernova at the center of M103, I think. It was missed by all the professionals and found by amateurs. So, and it turned out that some of the amateurs had told the professionals it was there, but it wasn't in their survey. The algorithms didn't find it. And there's a similar case, the M82 supernova, which was 2014 as well, I think, which was found by Steve Fossey at University College London and a bunch of undergrads who were having pizza while imaging it. And they found it because Steve, who knows the sky like the back of his hand, looked at the image on the screen and went, that shouldn't be there. And it was missed by all the algorithms because they'd learned that anything that bright couldn't be real. And so this is something I talk about in my book, actually, and something that powers us at the Zooniverse is that by having eyes on the problem, people who know what they're doing, and either by the web or reality, you could be surprised by the really unexpected stuff. And so we need the automated professional searches, but I'm convinced in 10 years' time we'll still be talking about discoveries of interesting things by amateur astronomers.
Yeah, why would you not take advantage of those hundreds of thousands of eyes that are always on the sky? Yeah,
I think that's a good point. And people human beings are very good at being distracted, and we're very good at being distracted by the unexpected, and that's rather hard to program. So I could build, even I can write an algorithm that would tell me when something bright is in the sky, but only me studying the garden will distinguish the ISS that goes over every so often from the alien spacecraft that's arrived. There isn't really an alien spacecraft. That's enough.
I'm sorry, I was just distracted by a message that we've got popping up saying that you mentioned your book, saying it's a great book, reviewed it for Astronomy Now. Everyone should buy it. So there you go.
Yes, I agree. You don't even have to read it.
Just buy it. That's the important
Just
thing.
buy it. That's fine. Yeah.
We say exactly the same about podcast downloads. You don't need to listen to it. Just download it.
Yeah,
So
the musicians have it terribly because you have to listen to at least 30 seconds of a song on a streaming service to get them paid. So they've actually got to be good. Yeah.
Oh, that's bad, yeah. As if streaming music wasn't bad enough for the musicians.
Right, yeah.
So the next question we want to ask you is from our good friend Mark DeVries, listener, Mark DeVray, who asks about the square kilometre array and the James Webb Space Telescope. Which do you think is going to generate the most exciting science? And if each one could answer just one question about the universe, what would you like it to be? There's a lot in that one.
Well, one of them should find aliens. That would be great. If I have to pick anything, that would be fab. And
you're going aliens rather than just biosignatures.
No, actual aliens. If I'm going to call the shot, that would be fabulous. Aliens which we can ask questions of on Zoom would be brilliant. So that's that. Which of them's going to be better? I don't know. They're both great. They're both hugely expensive, and they're designed to do sort of different things actually. So James Webb is an infrared telescope. The way to think about it is it's a first light machine. So it's looking for the first stars of the first galaxies, and we've got this slight mystery in that I think. One way of putting it is that the universe grew up faster than we expected. So we see in the deep Hubble images some quite well-developed galaxies already, even though we're going back to maybe 1 billion years after the Big Bang. And that's a bit of a mystery. So understanding the period from maybe half a billion years to 1 billion years after the Big Bang is crucial to making sure our theories are right. So I'm really looking forward to James Webb giving us those images. They will look like blobs, but they will mean a lot. Yeah. So the blobology of James Webb Space Telescope is the thing. SK is going to take a while to ramp up. The nice thing about it's a radio telescope, it's an array, so it's going to cover a large land area, but you can build it in bits. So what they call 1% SK, like a 1% of the dishes is already up and running. So the thing I'm most excited about, the full SK, when we get there in probably 20, maybe even more years' time, that'll fill in the gap. So that's every galaxy in the universe. But in the short term, what we're excited about, or I'm excited about, are transients, things that go bang in the radio sky. We know there are these fast radio bursts, which have been detected. We don't know what they are. We don't know how common they are. We don't know whether they're different types. Knowing astronomers, there will soon be a type 2 and a type 1 fast radio burst. We know they sometimes, but don't always repeat. They're not regular. And these things are really mysterious. And with the bits of SK that we're building now, and some clever computer processing, and maybe a Zooniverse project, but mostly the computer processing. I think getting a real handle on what FRBs are, and every time we've expanded into new sensitivity ranges in the radio sky, we found new things from pulsars all the way through to FRBs. So I think new types of radio transient will be the big story from SK in the next 10 years or so.
What's your best guess for FRBs?
Well, they've got to be something compact, so because they're so brief, so they've got to come from something small. So at least some of them are probably neutron stars colliding, things like that. But I'm not utterly convinced. So we see some of them repeat, and I'm not yet convinced that the ones that don't repeat, they may not be the same thing as the repeating ones. Right. And there may be more exotic phenomena, but it's going to be in the sort of black hole neutron star interaction kind of thing, I think, and maybe some exotic matter on the neutron star. We just don't know. We don't know enough about them yet. I can't even tell you what frequency they're most common at, and I can't tell you. The ones that repeat seem to jump about in frequency a bit, which that confused me. Something that does the repeats but does the thing differently every time. That's a bit strange. Maybe aliens, of course. But probably
there
not.
You've said it.
Yeah.
Well, thanks for agreeing to join us at such late notice, Chris, and it's good to know that there's so much that anyone can be doing to help advance science at any time of the day or night, and this is a really good time for people to get involved in that when for a lot of people who are furloughed and in unfortunate circumstances at the moment can occupy their minds in different ways and also advance professional science. Chris's latest book, which we reviewed a few episodes ago along with Matthew, The Crowd and the Cosmos, is a great read. You should go out and buy that. Thanks very much, Chris, and we'll see you soon.
My pleasure. Stay safe.
You too. Bye-bye.
Bye.
So, one for us guys. So I'm going to read out a question now from Glenn Diekman in Southern California. And he says, Dear Martian Overlords and Jen and Wing Commander Paul, what would happen if a small stellar mass black hole collided with a much more massive star? Could the star ever win such an encounter by pulling apart its rival, or would the singularity always be victorious? What might such an encounter look like? I love your show and never miss an episode because you make me laugh and I always learn something new. We're fooling somebody.
The black hole would win every time.
Every time.
Yeah, every time. Tear it apart. It looks spectacular.
Yeah, this is the thing. Like, I like this question. It's a great question. So thanks for sending it in, Glenn. I mean, in terms of having them kind of collide, that's not going to happen very often in the sense of just like there's a star, then there's like a black hole whizzing through the galaxy on like completely different orbits. Like they're not going to kind of just interact and collide. The chances of that happening are slim to none. But you know, if you've got like a binary system, this is probably when you're going to get some kind of interaction. And I have prepared slides.
Oh, slides.
So I know, right? So I'm gonna try and share a screen. I know, right? And test the technology.
Hold on to your braces, chaps.
I know, right? So let's see what happens.
I'm waiting.
Look. Okay. Do you see a slide with Glenn's name on it?
Diekman.
Excellent. This is what we're after. Okay. So, black hole star colliding. When this is what I was thinking about when I think about this question. So if you think about, you've got two massive stars in a binary system, and the more massive the star, the shorter its lifetime, right? So you'll never have two stars exactly the same mass. One of them will be a bit bigger, and that one's going to go boom first. And if it's a very massive star like Glenn is asking us about, then it is going to probably turn into a black hole rather than a neutron star. So there is a caveat with this infographic. This one shows a neutron star on the right hand side, kind of that swirly thing. The same concept applies if that neutron star was a black hole. So we've got the more massive stars exploded, it's turned into a black hole, but they're still in a binary system because you know, assuming that the explosion doesn't knock the other star out of this binary system, which it very easily could, but we'll assume that doesn't happen. And the two objects are going to continue orbiting each other. It doesn't really matter if the mass of the one is like, you know, a black hole or a star, you know, they're still going to orbit each other. If you place the sun with a black hole at the center of our galaxy, the planets are still going to go whizzing around, right? It's not going to, we wouldn't notice other than the fact that everything would go dark, right? But sooner or later, the other star is going to evolve. It's going to swell up into a supergiant star. And then that's when the danger comes. And this is where the black hole really comes into its own, because as it swells up, it'll start expelling material outwards. It'll puff up. And this material eventually gets to a point where it's no longer under the influence of the gravity of the host star, but suddenly the gravity of the black hole starts to dominate. And the black hole will just literally start sucking material away from this star, and it'll suck it into an accretion disk. And then this material will, you know, slowly spiral in. It'll get accreted onto the black hole. We'll get these really powerful jets of converting this matter into energy. You'll get beams of X-rays coming out, which is what you can see in here. And so basically, the black hole is just going to gobble up that star. And the star is never going to win. Eventually, the black hole will suck off as much material as it can. The star will die its death, and the black hole will be victorious.
Did you just say the black hole will suck off the star?
I did, and that is a little tidbit then for everyone listening, because I didn't really twig that coming out of my mouth, but you know, that's because I'm young and innocent.
Filth. Probably is filth. I can't approve. I can't possibly approve.
Yeah. But interestingly, this is someone people might have heard in orbits and stuff. You got two body systems, and you hear like the Lagrangian points. This little cross between the two lobes here. This is the Lagrangian point 1. So there's always these between two bodies, and it's a point where like the gravitational influence of the two bodies balances. So you can kind of balance something at that point there. So over to the left is where the gravity of the black hole dominates, and to the right is the star. And so there we are, Glenn. The black hole will always win. And now I'm going to try and stop screen sharing. Should we see?
So,
am I back?
I say.
So the mass doesn't matter at all. Even if it's a bigger mass star, it's still going to lose to the black hole.
Yeah, this is the thing, because I mean, the most massive stars that we know in the kind of modern day universe are maybe 100 solar masses or so, 120 solar masses. Know about Perseus, so there's not that much difference between them anymore that we can get. It's never going to win against a hole. It might take some time, but the black hole will win.
Yeah.
You were appreciated there, Jenny. There were lots of people excited about the slides in the comments.
Ooh, really? I missed that. Missed the comments.
Yeah.
It shows some kind of professionalism there, I think, which we're not renowned for on this show.
I think that was way beyond our normal capacity, frankly. Oh, I see a Chris North.
Well, yes, there's a Chris North here. So we have a director of public engagement for Cardiff University's Gravity Exploration Institute, our good friend Dr. Chris North. How's lockdown treating you, Chris?
Lockdown is not too bad. It's a bit odd not being in work, and it's a little bit hectic trying to work from home with the family and so on. I've actually sort of taken this week off as holiday. I was going to do it anyway. The intention was to be with family in other places, but that obviously hasn't come to pass.
Yeah,
so,
I was supposed to be in New York on Friday, as in tomorrow.
Yeah, I wasn't going to go that far, but so it means that I'm a bit of time in the garden, which the weather is good. I'm grateful for having the garden to be able to send the kids out into and be in as well. Maybe lounge around for a bit. Read a book or that kind of thing.
I suppose it's not one of those things where you think, oh, damn it, the timing's really bad to take time off work because we don't know how long this is going to go on for, and people are going to lose leave at the end of the year anyway, aren't they?
Well, yeah, and we're being encouraged. I mean, a lot of employers and Cardiff University is no different. Is encouraging people to, not to cancel their leave for two reasons. One, I think, is that it's good to actually take time off, work and have a break. And the second reason is that it's good to not use up or not save up all your leave and then find you can't use it later.
Yeah,
exactly.
So, Jed, I'll pass over to you.
Yeah. So we'll do some questions, if that's all right with you.
It's fine by me.
First question comes from Father North, which when this question came in, I was like, that's it. We got to do this one for Chris. Like, we can't not get Chris to answer his own dad's question.
He knows WhatsApp me, right?
Well, apparently he doesn't know that he can WhatsApp you, because he asks his questions to us instead. But anyway, so Father North asks, why are astronomers so sure that Muamua and Borisov are from outside the solar system? If the object were one half of a binary pair, somewhere in the Oort cloud, for example, then perturbed by a third, couldn't it be thrown towards the sun while the other was ejected at a greater than escape velocity? I mean, would more than one counter be required to give it the required velocity? So I guess the crux of the question is, how do we know that they are from outside of the solar system?
I mean, this is a good question, actually. So the reason that these two objects, so Oumuamua and Borisov, I did originally think it was Oumuamua was a comet. It was an asteroid. I was calling it an asteroid until I got told off by Alan Fitzsimmons, who told me that no, it's probably more like a fragment of a comet. Although I mean, it was an inactive one, a dead comet. That came through in 2017, I think, if I recall. And then last year we had Borisov
I think so.
in flying through the solar system as well. And that definitely was a comet. It had an atmosphere, a coma, and so on as well. Now, the reason they were flagged as being interstellar objects rather than objects in our solar system is because they were moving so quickly. Nothing in our solar system has any business moving that quickly. They're moving so fast that they will, escape the gravitational pull of the sun and leave the solar system entirely. Now, it's correct that that can happen within the solar system. So we think that most objects in the Oort cloud were probably ejected there by Jupiter, for example. Or Saturn, the major planets. Could it be something out there, as my father has hypothesized, that it was a binary object, two objects going around each other, and then a third object has come in and caused them to get flung, or one of them to get flung inwards, one maybe flung outwards. In principle, yeah, and actually that's probably why most comets that come inwards from the Oort cloud end up coming inwards, because they're sent in by some sort of encounter out in the Oort cloud. But these two objects are moving so quickly, so they're what's called their inbound velocity. Their velocity when they get out to infinity, out to way out of the sun's gravitational pull, is something like 30 kilometers a second. And nothing in the Oort cloud we know of can do that. They probably came from, well, if they didn't come from the Oort cloud, they came from another solar system. So if they came from that solar system, they probably got ejected by an encounter with a massive object. So if you do get a three-body encounter, so you get maybe a binary system and a third thing comes in, and this works whether it's asteroids or stars or black holes or whatever, then the lightest of those three is almost always ejected at very high speed. You can think of that as if you think about sort of conservation momentum, you're going to have the same momentum given to each object, but the less massive one will have greater velocity, and so will be flung out. And so it's probably they were the small part of some sort of encounter, almost certainly in another solar system. I mean, we measure these if we think about comets coming into the Oort cloud, or comets get ejected from our solar system by say Jupiter. They have eccentricities, which is how elongated their orbit is. Of about 1.01 or 1.03. So this is a measure of if that eccentricity is 1, they're on what's called a parabolic orbit. They will just escape. If the eccentricity is 0, they're a circle. So it gets longer and longer when you get out to 1, and then beyond 1, they're on these hyperbolic orbits. So comets are normally, if they're on that verge, normally at eccentricity about 1.03. These had eccentricities of 2 or 3, not 1.2 or 1.2.
They are basically
really eccentric.
They're kind of coming in and kind of just skimming and then sailing off again.
Yeah, and it's a one-time pass. I mean, the estimates are that there's probably one a year of these objects, but they're so fast, you have to be able to spot them. And these all-sky surveys are good for doing that. They're also if they're things like Oumuamua, that was small. It was dark. So really hard to spot in your telescope as well.
So I guess to sum it up, it's because they're going too fast and they're just flying straight through us.
Yeah, it's not just that they're going too fast; they're going way too fast.
Yeah, way too quickly. So our second question comes from our good friend Mark de Vries, Mark Fridge. We like to say, we're asking all our guests this question. This is the thing that I'm letting all our little secrets out, all our little conversations that we have while we're recording. They're all going to come out because I can't keep a secret. So you're gonna get nice little tidbits. Anyway, the question is: square kilometre array or JWST? Which is going to generate the most exciting science? And if each one could answer just one question about the universe, what would you like it to be?
That is a good. So these are two of the biggest projects coming online. I know you've spoken to Chris Lintott, who's outlined the projects already. So I don't need to go into too much detail. But I think if you look at their science goals, then what JWST, what the Webb is going to do, is to look at the first stars in the universe, or the formation of the first stars, when that was and how that was. So we'll be able to see the first galaxies certainly. With James Webb, just by looking at these longer wavelengths, looking at that redshift, that stretched light. And it will be able to take very high res images of other solar systems and potentially even other planets. But whereas SKA is going to obviously look at the radio waves. I was looking at you could think of this as what's the wavelength range. So what's the range of wavelengths? So JWST goes from about 6 microns down to 14 microns down to about 0.6 microns or something like that.
Yeah, something like that.
So that's what's that, a factor of, call it 20 in wavelength. Whereas the James Webb, whereas SKA goes, its wavelength range is a factor of 1,000.
Yeah.
Or more. When it's up at certainly a few hundred up at when it's fully established, and so there's much more sort of parameter space to explore. The other thing about SK, it feels to me like there's got more scope there for serendipitous discoveries, for discoveries of objects that we've never seen before. So we've got the things that we know we don't understand, that we want to know more about. So these fast radio bursts and so on that are blinding us every now and again. But there's likely to be other things out there that we've just never done. Square kilometer arrays looking at such high resolution of bits of the spectrum we've just never seen in that kind of resolution before. In some senses, it feels to me, at least, maybe this is unfair, we know a little bit more what to expect with James Webb than we do with SK. It's still going to do amazing science, and the questions it will answer are going to be amazing, and it will produce prettier pictures. There's no denying that. So in terms of what will get the press attention and what will be in the news and all over the web, and no pun intended, will be James Webb. But the SKA, some of the science there, although potentially hard to visualize, looking at things like magnetic fields and the role of those in and all sorts of things. It's a favored question of astronomers of considering magnetic fields, and have you considered the effect of that on whatever your science is.
Every seminar, it's like, have you considered magnetic fields? And everyone just goes, no.
Well, they're hard, and we don't really understand them that well.
Yeah.
We understand magnetic fields. We've done that since Faraday's time, but we don't always understand their interactions with the interstellar medium because they're hard to measure. You can't see the magnetic field. You have to look at its effect on other things. So you look at the way it normally the way it polarizes light, so the way it causes light to the wave to oscillate preferentially in one direction over the other. I'm doing the polarization dance there on screen, I realize. It'll oscillate in one direction or the other preferentially, and so looking at that tells you a little bit about the magnetic fields. If that is rotated, so there's a nice thing called Faraday rotation, where as you change frequency, the amount that polarization changes with frequency tells you the strength of magnetic field it's passed through. So no magnetic field, that polarization direction is the same at all wavelengths or all frequencies, but there is a magnetic field. As you look at different frequencies, that kind of twists slightly.
Slightly being the key word.
Ever so slightly. You do need to know what's between you and the object you're looking at. So you need to know about how much gas there is there, how much ionized material there is there. That's something that's hard to not always easy to measure. But having much more detailed observations of this will allow us to study that in much more detail. And the other nice thing is that it can look at if the processing is there, it can look at several things at once. So because it's this array of telescopes, certainly at the low frequency end, where the individual telescopes, rather than being at the high frequency end, they're dishes. They look like a radio dish. Whereas at the low frequency end, they're more like this pen.
Just like sticks out the ground, aren't they?
TV antenna. Well, it's not a TV antenna, it's a radio antenna. But it's a radio antenna stuck in the ground, or thousands of these things. And the nice thing about them is each antenna can see radio waves coming from all over the sky. But what happens is when you get, I have a second pen. I have a stylus and it's plastic wrapping still. When you get, which I was going to play with tonight, but I haven't had time yet. When you get a pen and a stylus, or two radio antennas, as we'll pretend they are, and you combine their signals in the right way, then you can actually start to look in specific directions. And that's all done through just by the time difference. If a radio wave comes in from over here, it hits that detector slightly before it hits that detector. So you look at the timing between the two. And the nice thing is, if you store all the data, you can sit there and change those times. You can store the data. You can apply different time changes, time differences, and actually look. One time difference will let you look over there, another time difference over there, another time difference over there. Now, the catch is that's a lot of data. These things produce a lot of data. Yeah. But it does have the potential that you could say, well, if we've got that, then if we know, for example, it's a fast radio burst we want to study, well, let's point one of our directions at that and sit there and wait and then do some other stuff. Maybe not at that for 24 hours a day, but you know, you could dedicate some stuff. You could do much more targeted approaches than you can with a normal telescope if you've got the power and the processing to do that.
So I think the answer is SKA that you're most excited about, maybe.
I think because of the serendipity, because of the unknownness. That's not a word. It is now. Of the
anything goes on
science it's going to do.
Awesome. Thank you so much for answering the questions. It was great about the SKA, like stuff that I didn't really know or / had forgotten. So yeah, thank you so much, Chris.
No problem.
Blame the people teaching you.
Sorry? The people teaching you.
Because you didn't know. I blame the people teaching you.
Yeah.
Well, thanks very much, Chris. It's been an absolute pleasure speaking with you. And now we're going to go over to, we're heading over to California now, actually, because we're going to go and speak to the Senior Astronomer and Institute Fellow at the SETI Institute, Seth Shoshtak. How's lockdown treating you, Seth?
Well, the lockdown is not doing much, but, I'm going slightly stir crazy. But I think the people who know me best would say that's no change in my situation.
So we've got to ask the first question. Is that a real background or is that a fake Zoom background you've got there? Because that's
No. This is the real deal.
Wow.
Oh, wow. What are we looking at?
I mean, it's just my den. There's nothing special about it.
I don't know. I see something with a cog or a wheel in the background.
Yeah, I think you're all too young to remember film.
No.
That's a scanner.
I am.
That's a scanner. I'm using it to transfer some 16 millimeter films that I've made, including the Invisible Universe, by the way, onto digital format so I can see them without setting up the projector.
Fantastic. So what is new and big in the world of SETI right now? Where are we at?
Well, SETI, obviously all the practitioners, which the total number of which is not terribly much greater than the number of people on your screen right now, obviously they can't go to work, but they can still use the instruments because the instruments can be operated remotely. So that's going on. That's radio SETI, where we're trying to, pick up signals that some Klingons have deigned to broadcast into space, at least partially in our direction. But the other things that are going on, we're going to be doing some experiments using the VLA in New Mexico. That's very large array. And of course, at the moment, SETI is just an American enterprise. In fact, I would say it's just a Californian enterprise. And in fact, more than that, it's just a Northern California enterprise within 50 miles of where I'm sitting. I'm in the Silicon Valley, but 50 miles away is Berkeley, California. Some of you may have heard of it. And Barclay, I guess, in the UK. And it's and they have the big Breakthrough Listen project. So it's a very, very tiny enterprise, and that's a problem. That's a problem because and it's all governed by money. But look, what's happening? I mean, I think the most interesting things are the discovery of exoplanets. But if you actually look within the SETI community itself, it's the matter of having better equipment. Speeding up the search by basically applying more computer power to it, including machine learning and things like that.
So we've had a question from a listener, Rayful Tumbles, and he said, could you discuss what happens when we discover possible habitable planets? What happens at SETI? What do you get excited about? What do you do when we found something that looks habitable?
Well, it depends on when the answer is given. If we're back in the fall of 1995, when we found 51 Peg, or the people actually down the street. Well, no, actually it was the two Swiss astronomers who found it. By the way, that's an interesting question. Why it was found by Swiss astronomers? When you look at astronomy around the world, who does the most astronomy research It's all the formerly seafaring or currently seafaring countries, right? Because astronomy used to be useful. I don't want to say it's not useful today, but you know what I mean. Okay, so they all set up observatories because they needed the, they needed the time, right? I mean, it was a matter of navigation. So the countries today that are big in astronomy research tend to be countries that had navies, that, or in the case of the Dutch, didn't have a navy, but they had a lot of merchant ships and so forth and so on. So, it was kind of a mystery to me why it was that the Swiss found the first exoplanet, because, Switzerland doesn't have a whole lot of coastline. And and I asked one of the guys who found it, Michel Mayor, one of the guys who found this first 51 Peg, the first exoplanet around a normal star. And he said it was because they had this watch industry. Very expensive watches come out of Switzerland, and the watch companies wanted to know the time very accurately so they could calibrate their watches. So they set up observatories. Anyhow, that's kind of a side point, and that's
a great side point.
But it's a great point. Yeah.
Yeah. Well, the story goes on for another hour and a half, but
we're good. Keep going.
Yeah. Right. Anyhow, yeah. So when the exoplanets were first being discovered, there's every 2 weeks there was another one. Of course, we swung our antennas in the direction of these star systems, thinking, "That's it, Bob. Right over there. That's where the aliens will be." But what has happened in the past, 2-3 years now, is that we have enough data to say that essentially all stars have planets. Maybe it's 80%, maybe it's 90%, but 80% in astronomy is the same as all, right? So
as an astronomer, can confirm.
Yeah. If you get anything right within a factor of 2, that's really high precision. So I mean, that wouldn't work for all endeavors like paying your taxes, for example. But that's.
But when the universe is so big, right? A factor of 2 is probably fine.
Maybe you think it's big. I don't know. Compared to anybody else's universe, is it really big? I don't know. But in any case, we would get excited about these exoplanets in the early days. But once we figured out that, well, point at any star. I mean, not an early type star, not a big blue O-type star. They don't live very long, so no chance for Klingons to evolve on a planet around there. But if you point at any star, even slightly larger than the sun, all the way down to M dwarfs, the chances are it's got planets, whether you found them or not. So there's no point in getting excited to finally address the question of the listener or viewer who might have expired from old age by now. To finally address that question, we don't get all that excited about new exoplanet discoveries. Oh, this might be an Earth-like planet. I mean, there was one in the news this week because there are just so many of them out there. We might as well just point at the nearest star systems.
It's just old hat now, finding a new exoplanet.
Yeah, it's like looking for ants. When you only know about one ant colony, you get really excited about that. But once you figure out that ants are everywhere, you just go to the nearest backyard, right?
Yeah, it's true. Back when extragalactic astronomy was really getting going, people would find a new, slightly more distant galaxy and be like, "Oh wow, this is amazing!" And now, we just know about so many. It's only really going to be the first galaxies that we've talked about a little bit today that are really going to get people going and really be excited. People used to do whole papers about finding a galaxy. It doesn't happen anymore.
Yeah, it's like, it was a big story, I guess, when the first lottery winner showed up in California. But there have been so many now, nobody cares. I don't know. That's not a very good analogy, but you know what I mean. Is there a reason that Paul is totally frozen? Is it cold where he is?
It's England. It's always cold.
Yeah.
Yes, well, I'm going to assume that Paul's frozen and can't continue. So what we want to ask a question from another listener. In fact, a question that we've been asking to all of the people that have been joining us, all of our guests, and that's the Square Kilometre Array and James Webb Space Telescope. Which is going to generate the most exciting science in your view? And if each one could answer just one question about the universe, what would you like it to be? And I think we can probably guess.
You can. And since everybody else who's addressed this question was named Chris, I find myself unworthy of adding to what they have said.
I'm Chris, we can do.
I'm a radio astronomer, so it's just like you guys, except the wavelength's a little longer. But So naturally, I'm going to favor the SKA, the square kilometer array. It's about 10 times the area of, other things, but it's only about 10 times. Now, 10 times would mean you're looking at maybe 30 times as much space at any given sensitivity. So that's a big deal. And it would be great if the SKA, which can be used for SETI, were to pick up a signal. I think Chris North already suggested that. Maybe Chris Lintott also, I think he did as well. But, it's going to do astronomy of stuff that's small because it has its big advantage, other than covering up a lot of European real estate, which is always a good idea. I mean, its big advantage is that because it's an array, right, it can see fine detail. And so you're going to learn a lot about things like radio galaxies and so forth, just by being able to make, if you will, better radio pictures. A terrific example of this was this, black hole photo. That was a radio telescope photo, of course, but it was a virtual telescope. It was a bunch of antennas spread around the world. So it's sort of like an SKA, except it's, many tens of thousands of kilometers across, but that gives it the high resolution to see these details. So I think the SKA is going to be pretty nifty. And because you can siphon off some of the data stream there and use it for SETI, SETI is sort of running on alongside that, just like an experiment on the Large Hadron Collider. You've got your own experiment and you just take part of that beam of collided particles over to where you are and you do your own work. So there's that. But it has to be said that when people ask, and they occasionally do, along with all the embarrassing questions that people ask me, like, are the aliens really going to land in Swindon and, destroy everything?
That's a good idea, by the way.
Yes.
I live near Swindon. That's not a bad plan.
I've heard that said by various people from the UK, but, of course they're wrong, because when you think of how the UK is viewed from outside the boundaries, the only places they've ever heard of are Swindon and Clapham Junction, and that's pretty much it. So in any case, where was I? What was I talking about? I don't even know. Oh, yes. When people ask, how are we going to find life in space first, right? There's kind of a debate about that, because on the one hand, you could say, okay, it's going to be a square kilometer array, or all the radio telescopes that are looking now, we're just going to pick up a signal. Now we know there's somebody out there at least as clever as the inhabitants of Earth. That would be, that'd probably make it to the papers, right? At least the tabloids. So that's a good thing. But on the other hand, maybe the first life we find is with the James Webb Telescope, when we see oxygen in the atmosphere of some planet, where we don't even see the planet, but we get 1 pixel's worth of light coming from it, put that through a spectroscope and see the lines of oxygen. And that might be the fastest way to find life. The other way to find it is to find it in our own solar system, for which you need neither of those telescopes.
What would be your prediction as the one we find first?
Well, as I say, people do ask me that, and then I launch into an answer and they walk away quietly. I like to bet on SETI, and in fact, I gave a talk, I don't know, what is it, like 8 or 9 years ago in Germany, in which I said, I'll bet every one of you guys a cup of coffee that will find ET within 20 years. And I still stand by that. My wife is buying a lot of Starbucks stock, actually. and that may happen, but, the NASA's chief scientist 3 years ago said, well, we're going to find life within 20 years. And she meant by finding it in our solar system, microbial life. So microbial life is great. It's biology after all, but it doesn't talk back to you. So I'm still looking for intelligent life, and I think we're going to find it before all you people go on pension.
Cool.
Excellent.
I'm liking that.
That's perfect place to
I like the commitment.
Yes.
Which is not something we always get. Sometimes people are a bit wishy-washy, and I just love that you're like SETI, straight in.
Yes, people have said I should be committed.
We've actually asked a comment in the chat saying that this is from Averted Vision, saying, hi Seth, your bookcase looks exactly like Commander Hill's. And actually they do. Like your backgrounds, yours and Paul's backgrounds.
Yeah.
That was painted by my children earlier today.
The Union Jack?
Yeah. They painted that.
Did they actually?
They did.
It's
They literally.
very good.
They were actually. How's this for a weird story? They were entering a competition online at the Tank Museum to win something, and they needed a Union flag in the picture.
But Paul, it's not that impressive. They are 40.
They'd leave me alone.
Well, thanks very much, Seth. That's been wonderful speaking to you. Where can people hear more from you? And in particular, where can Mike, one of the panelists who asks about hearing that hour and a half on astronomy for navies, where can he hear about that?
Astronomy for, sorry?
For navies. The navies.
Astronomy for navies.
Astronomy. Where can people hear about that?
The Navy doesn't care about it much, care much about astronomy anymore. Although, you know, I grew up in the Washington, D.C. area, and I frequently would go to the U.S. Naval Observatory, which was set up to keep time, of course, but they do other things as well. You know, just have them go to SETI.org. That's where they ought to go.
Yeah. Wonderful. Lovely to speak to you, Seth. Take care.
Bye.
Thank you. Bye.
Okay, so next we'll divide a question between ourselves, I guess, and we're going to look at a question that came in on Twitter from Seamaster GMT, who said, you talk about the extremely large telescope, the ELT, in April's episode part 1, but how on God's green earth do you keep a mirror like that clean? Over time, contaminants must occlude the vision of the mirror. Do they run a Swiffer over it? Well, kind of, almost, no. So I
love how you very gently let him down then. It was like, kind of, almost, no.
What they do, they lower someone on, you know, like Mission Impossible. And they go.
You just know they've got a little canister of air like that.
No, they just blow it. Like that. That's how they do it. That's how they do it. It's the interns. They drop them down on ropes.
And that would have been my guess too. So luckily I went to the European Southern Observatory to ask them directly for the real answer. Turns out
good idea.
They've said that the ELT mirrors are protected by the giant telescope dome and don't need very frequent cleaning. From the experience we have from the VLT, that's the Very Large Telescope that the European Southern Observatory run, we know that we only need to clean and recoat them to maintain their shiny surface once every 1.5 years for mirrors facing up and once every 5 years for mirrors facing down. For this, the mirrors are removed from the telescope and brought to a special facility for cleaning and recoating, a process that takes about a week for the large mirrors. The ELT team is also investigating options to clean the mirrors without having to remove them. And you can actually go and see a video of how they do that if you go to eso.org/public/videos/VLT-mirror-cleaning. Hope you remembered that.
What a world we live in that, you know, I can't get bread flour at the moment, but ESO can get their mirror clean in a week.
I know.
And I have a little anecdote to add from my time in, guess where? Australia.
Australia then?
There's clearly Newcastle.
Have I not mentioned this before? I thought I had, but
bridge in Newcastle behind you.
Yeah, it's clearly Newcastle.
So I'm going to try and do the magic screen sharing again.
Oh, here we go. Here we go. Right.
Here we go. Oh, okay. Hopefully you can see a slide that says Seamaster GMT.
Oh, look at that.
Look at that.
She's done graphics and everything. It's incredible.
Put some effort into this. I have. Anyway, I thought this would be good to do because these are my photos, which means they're copyright free. So we don't have to worry about anyone coming back to bite us after using them. Look at that. So when I was in Australia, and I went up to Siding Spring Observatory and the AATs there, and we went and kind of, we saw the telescope and everything. We also got to go and see all the gubbins, so instruments and things like that. And this is where they re-illuminize the AAT mirror, because the AAT mirror, for the wavelengths it operates at, its surface is covered with aluminium. And
aluminum
so what they
for our
do
American listeners.
Aluminum, if anyone's listening in America land. And so what they do is they take the mirror off. So it's a 3.9 meter primary mirror in the AAT, and they take it off and they put it in this, and this is a vacuum chamber. And what they do is they evacuate the air till there's only 1 part in 100 million left, right? And then what they do is they have little aluminium rings on tungsten filaments, which I'm hoping you can see now. It's just cropped up. This is an example of what they look like. And so they heat up these tungsten filaments, and this evaporates the aluminium, and then it coats the mirror in a very, very smooth and uniform way. And as you can see in the little note that I've put on there on the slide to remind myself, the coating is 0.0001 millimeters thick. So it's a very, very fine layer.
You're telling me that thing there that looks like my 7-year-old built it coats the mirror that well?
Yes, because
Bloody
it's
hell.
in a vacuum, it disperses the atoms in a very uniform way.
Well, my pipe is going up. Bloody hell. Frankly, bloody hell.
It's great, isn't it? So
that's brilliant. I love that.
Yeah. I thought that would be a nice little kind of add-on. So I know it's not the ELT, but yeah, they do this. All telescope mirrors have to do this, have to come off for cleaning and for recoating, just to make sure that they're reflecting as much light as they need to.
Yeah, and it's also worth thinking, how much care you put into it when you've got your own telescope optics over, say a window that you would just use a Swiffer or a squeegee or something. You're not going to do that on just an amateur telescope. So it's got to be something a lot more serious when it comes to the big, expensive equipment. And it's almost remaking it, certainly recoating it. Yeah,
exactly. And of course, this recoating is happening after they've been cleaned. Because you can't have, if you've got any dirt underneath that aluminium, it ain't going anywhere ever again.
Okay, well, now we'll go on to move on to our final guest, and we have waiting for us, hopefully, our good friend and the most knowledgeable person we know on all things US spaceflight, Gavin Price. Gav, are you there?
Looks like.
Hey! Glasses charged. How's lockdown treating you, Gav?
It's going well. I'm using the time to utilize and try and research and possibly put together a book on Apollo.
Oh, wonderful!
Oh, at last.
Possibly.
No.
There is no try, only do.
Cross that word off. It's going to happen. Yeah, look, people on the chat
are going. Yes. Dustin has said, "Woohoo! The Apollo savant."
Yeah, it's something I've considered for a while, and I've been encouraged by a lot of my friends online. But if you're trying to write a book about Apollo, what angle do you write about which hasn't been covered before?
Yeah,
you can talk the astronauts; they've had their biographies written. I think Neil Armstrong's had 5 or 6 books written about him. You can't really talk about the politics because that's been covered extensively. Then you talk about the hardware, Kennedy Space Center, the Saturn V, the Apollo Command. It's all been done. So trying to find an angle which is new and fresh and will bring some new information out is quite difficult. But I think I found an angle which.
I'll hold it here. Don't tell us. Leave it as a surprise when you write the book and you send us a copy to review on the podcast.
Will do.
Well, as we're 50 years and a day from Apollo 13 limping its way back to a safe return, can you give us a brief overview, Gav, of the Apollo 13 mission and what happened on the way to the moon? So kind of the mission as it's occurring now 50 years ago.
Yeah, so I think a lot of people watching this this broadcast will be aware that it's 50 years since Apollo took off from the moon, and they launched 50 years ago last Saturday. And on Saturday evening, myself and my partner, we sat down to watch the movie Apollo 13. Great movie. It's very well done, very well thought out with input from the astronauts and the flight controllers who worked at Johnson Space Center. But after I finished the movie, I thought, I don't actually know a lot about the mission and what went on. So what I decided to do was go through the air-to-ground transcripts, the communications between the crew and the spacecraft, and the mission controllers on the ground, or the CAPCOM, the only person who would talk to the crew. And there's this website called the Apollo Lunar Surface Journals.
Have you seen Apollo in real time too?
Yes, I've watched a bit of that, but I've purposely shied away from looking at that this time, as opposed to Apollo 11, because on this Surface Journal, it's written by NASA historians and people who've put together so many books on Apollo. And what they do, while the crew are talking to the Capcom on the ground, the people who put together this website will actually break down what they're talking about. So if they're talking about a certain system which is broken, and how the astronauts are going to fix that system, it'll give a graphic and a brief description of what the astronauts are talking about, so you can really get down in the mud and try and understand what's actually going on, rather than the astronauts reading down a whole bunch of numbers and things that the general public, like myself, are not really keyed up on. So I spent the last 6 or 7 days just diving into that really, and trying to understand what actually went on with Apollo 13. One of the things I found out was the oxygen tank in the service module, just behind the command module where the Apollo astronauts sort of lived on their way to the moon. It exploded, and that explosion can be traced back to 1962, in fact. So this wasn't something that happened over a couple of days or a couple of months. This explosion had been in the making for the best part of a decade.
Why is that?
So, as you're probably aware, there were over 20,000 contractors involved in building the software and hardware for Apollo. And the specifications were given to North American Aviation to build the command and service module. The cylindrical service module, which held the consumables and which would provide electrical power to the command module, the sort of conical shaped structure where the astronauts lived. And the specifications given to North American Aviation, the systems were supposed to run on 28 volts. So they built the spacecraft and the oxygen tanks to 28 volts. Unfortunately, the ground support equipment at Kennedy Space Center, where they tested all these systems individually and in an entire stack before flight, they were rated to 65 volts. So when they came to do tests, the electricity that was running through these systems was more powerful than what they were designed for.
Yeah.
And the tank that actually blew up on Apollo 13, it was due to fly on Apollo 10 in May last year, or May 1969. And they removed the tank to do some maintenance on Apollo 10. And rumor has it, it was dropped 2 inches. And that affected a drain line at the top of the tank. And one of the things they do before a Saturn V launch is something called a countdown demonstration test. And one of these tests would be wet. And what that means was they'd fuel up the Saturn V, they'd fuel up the hydrogen and oxygen tanks, which would power the fuel cells. Test that everything's okay, then drain all the fuel out. But because one of the feed lines on the oxygen tank was knocked ajar, they couldn't actually drain this oxygen tank in the normal way. So they decided just to heat the tank up with a couple of fans and heaters. And they ran those fans and heaters, I think it was for about 8 hours. And of course, it was running at 65 volts rather than 28. And the temperature inside the tank, I think it went up to 1,000 degrees Fahrenheit. And no one knew at Kennedy Space Center it burned off all the Teflon insulation within the tank. Of course, they sent it on its way to the moon then on Apollo 13.
Wow.
So it was a whole chain
It's
of
a whole
events.
series, isn't it?
Yeah, and ultimately it was a breakdown in communication. You have something within the Apollo program called prime contractors and subcontractors. So a prime contractor would build things like stages of the Saturn V, the command and service module, and the lunar module. But even for the prime contractors, they didn't have enough labor, enough manpower to build these systems. So then they'd subcontract out certain subsystems within our overall structure. So a subsystem would be the oxygen tanks for the service module. And the specifications, when they changed, they weren't communicated to the subcontractor.
It's so frustrating to think that that was just sat there all that time, just waiting to blow when it came into use, and people were launched with that in the spacecraft. But then also so incredible to think that you could have an explosion like that in a spacecraft that ultimately didn't blow up the spacecraft or rupture the skin of the spacecraft. The astronauts were able to survive. So given that as we look at the calendar now, 50 years from their return to Earth, what were the kind of decisions that were going on in the spacecraft and at mission control now, and the kind of threats that were ahead?
So I think it's interesting, when I've been diving into the air-to-ground transcripts, is the flight director, Gene Kranz, quite rightly, he got a lot of praise in the movie and the subsequent press releases for the role he played in leading the teams in mission control to get the crew safely back to Earth. Gene Kranz was only on shift for, I think it was about 2 hours just after the explosion. And he was sort of fire shooting immediately. What are we going to do? What systems are we going to shut down? He then swapped his shift out with another flight director. And that's when Gene Kranz led a Tiger team to actually look at some of the long-term problems that were going to occur, 3, 4, 5 days down the line. The next person on shift was a flight director called Glyn Lanny. And that's when his shift really started to bottom out the procedures and stabilize the situation. And I've spoken to a couple of flight controllers within the last few years, actually. And a lot of them have told me within 2 hours of the accident, they were confident they'd get the crew back home. But then they went on to say, we'd get them back home. We didn't know if we'd open up the hatch, they'd be dead or alive. They were confident of getting that spacecraft back to Earth.
Yeah. And of course wasn't there, now I'm aware that a lot of my knowledge of Apollo kind of blends in from the book to the film, particularly Apollo 13, and it's difficult to separate the two when it's been a while since you've read the actual books and Jim Lovell's book. But wasn't there also an issue that they weren't sure whether the parachutes were going to open and that there was bad weather, or was that from the film?
So I can't really comment on the parachutes and the bad weather because I haven't got that far in the air-to-ground transcript yet. So I know there was a typhoon within the vicinity of the Pacific where they were looking to bring them down. I don't think that was an overriding concern. One of the big differences I've picked up on between the film and the actual timeline for Apollo 13 was that I couldn't see many decisions being made on the hoop, sort of knee-jerk reactions. A lot of those decisions that were made as the crew was sort of stranded in space, they were thought through, then they were simmed on Earth in the simulators, read up to the crew, and the crew repeated them. And actually, a lot of the procedures, I don't know if you can remember in the film, one of the burns of the lunar module engine to push the spacecraft stack back to Earth, Jim Lovell is sort of controlling the lunar module manually. Yeah. And he's got the Earth bouncing around in his window. He's trying to keep it centered in the window. And diving through the documents, they'd actually simmed manual navigation on Apollo 8 the first time they went to the moon in the Apollo program. And in the lunar module, they had procedures for that manual burn as well. So these things had really been thought about. There was very little that NASA didn't think about in terms of what could go wrong, what procedures do we need to have in place to mitigate such disasters.
Yeah. And one of the questions that's come in for us as we're going through this is, was there such a thing as software on Apollo? Wasn't all the computer processing a physical process?
So I've been reading a few books about the Apollo guidance computer. This sort of briefcase-like structure which was fitted into, there was one in the command module and one in the lunar module for the lunar landing. And the way the astronauts interacted with the Apollo guidance computer was with something called a disk key. A couple of numbers, a 5-level display. And the Apollo guidance computer is a bit of a misnomer in that after the Apollo program started, MIT were going to design the computer to guide the spacecraft. That was going to be its primary function. But NASA since realized, after they gave the contract to MIT, that they would be more accurate guiding the spacecraft from the ground. So you know the deep space sky network today that we track spacecraft around Mars, Juno around Jupiter. They've got dishes in California, Madrid, and I think it's Canberra in Australia, equally spaced 120 degrees apart around the globe. So you have global coverage. They could actually track the spacecraft more accurately from the ground than what the computer would. So the computer was actually a sort of redundancy system for navigation. And I know at the time the engineers in MIT were quite pissed because their primary function for the computer was taken away. Well, what they got was something bigger entirely. The Apollo guidance computer actually became the digital autopilot. That was the thing that would fly the Apollo spacecraft in terms of deep space maneuvers, working out the velocity changes, how long it needed to burn for, setting the right attitude of the spacecraft before it needed to burn as well.
Yeah.
In terms of the software, I'm not a software engineer. There were software programs written for the Apollo guidance computer. And these software programs were very limited because the memory in the computer was limited as well. So the astronauts could actually key in a program, return to Earth. And if they were around the moon, the program would actually fire that spacecraft to get them back to Earth, as long as the astronauts uploaded certain parameters that were given to them from the ground, whether that be attitude sightings from star sightings, how much velocity they needed to gain in feet per second, things like that. So it was a very capable system in the end. It was fundamental in actually landing Armstrong and Aldrin on the moon. They couldn't have done it without digital autopilot.
Yeah, it's incredibly capable when you think how primitive it was and just how much computers came on because of what was done through the Apollo program. But finally, we've got an email from Peter Ellinger in Sheffield, England, who asks if we were aware of the BBC World Service podcast, 13 Minutes to the Moon, which I'm not familiar with. But Peter says that season 1's on Apollo 11 and the current season 2 is on Apollo 13. Not a minute-by-minute playback, says Peter, but plenty of stuff from the astronauts, their families, mission control, and the backroom boys and girls. Great soundtrack too. All in all, something the BBC has done right for a change. Is that something that you've heard, that you've listened to, Gav, that you'd recommend?
Yeah, certainly. I believe it's from primarily produced by a chap called Kevin Fong, who used to work for NASA on the space shuttle program. And I believe he's actually stopped the podcast at the moment because he is a doctor and he's gone back to work for the NHS in the middle of the coronavirus, which is, is very admirable. I did listen to the 13 Minutes to the Moon podcast for the Apollo 11, but I've been so absorbed in Apollo 13, just reading about it, I haven't actually managed to get a chance, but I know Kevin does really get down into the dirt with these people who were instrumental in bringing that crew back home.
We've got a few people actually making comments about the 13 Minutes to the Moon podcast. Tony Horton has said that they're brilliant. Averted Vision has popped back up saying that the soundtrack is absolutely stunning. It's a great watch. I guess that's to do with the podcast. Maybe not. I don't know. But yeah.
13, the film.
Or is that Apollo 13, the film?
The film?
Do you reckon? Because I mean, if it's a podcast, it's not going to have...
You're not going to have visuals.
Visuals. Well, I don't know. We've got visuals.
Here we are.
With visuals.
Can I just make another point on Apollo 13?
Yes. Averted Vision has said, yes, the film. So thank you for that.
Carry on, Gavin.
Yeah, I think it's interesting to compare the architecture that NASA went to the moon with Apollo back in the 60s and 70s. And for those who are familiar with the Apollo architecture and actually how NASA got to the moon, they were sending 2 spacecrafts, the command and service module, which the astronauts would launch in, and ultimately which they would come back through the Earth's atmosphere, and the lunar module, which would take 2 astronauts down to the lunar surface. They could do an EVA, pick up some rocks, come back up and rendezvous with the command module around the moon. Now, if we look today, and some of the architectures that are being put forward for going back to the moon, we don't have similar architectures in terms of that level of redundancy. So if you take Orion, I think on Artemis 3, they're planning to send a crew around the moon in this new Orion space capsule. If something like Apollo 13 happened on Orion, the astronauts are dead. There is no lifeboat scenario there. You know, they're going to be stuck in orbit in the solar system for forever. And even with something like revolutionary as Starship, it's one system. And if that system goes wrong, there isn't a lifeboat scenario. There's nowhere else that astronauts can sort of transfer to, like the lunar module. So I think it's very interesting to compare, even though it was 50 years ago and what we would view as primitive technology today, the systems we're going to go back to the moon with, if something untoward was to happen, it's very unlikely those astronauts would get back safely.
That is a terrifying thought as well. I mean, it shows what confidence they must have in the architecture that they're building for Artemis, the next moon missions. But also, it's quite frightening that they're not building that redundancy into it.
Yeah, and one thing I've learned about Apollo, certainly the transition from the Apollo program into the shuttle program, is that one of the main reasons Apollo succeeded was the level of testing they did within the program. They were flush with cash during the Apollo program, and they can do a really extensive testing program, and not just testing the entire spacecraft or subsystems, but even individual components. Things like microchips were tested in their thousands before they ever flew. And you can sort of see that the testing program gradually fell away as they transitioned to the space shuttle. And ultimately, it was testing failures and management failures which killed 14 astronauts on the space shuttle. And I don't really see that level of testing. I haven't seen that level of testing since Apollo.
Yeah. Well, thanks very much, Gavin. It's been an absolute pleasure speaking with you. Just as a final thought, is it too early to say when you're expecting your book to be completed, or is
I'm in the very, very early stages, so you're probably looking at a couple of years.
I can't believe you've not got the project plan. Thanks very much, Gavin. Take care.
Thank you. Bye.
Bye.
If anybody does want to follow the remainder of the mission with the capsule and mission control audio, the spacecraft details and mission photography, just go to apolloinrealtime.com. And as Gavin was saying there, I've made a note here, Google Apollo Lunar Surface Journal if you want some of the more of the jargon explained as well. Certainly, Jen, I know that you've been using Apollo in real time quite a lot, and for the Apollo 11 mission that they ran on there too.
Yeah, I totally did not set an alarm for like 4 o'clock in the morning to hear the Houston, we've had a problem.
Is that when
that didn't happen? No. No, that totally happened. And I stayed awake for about 40 minutes listening. And you could just hear it all kind of slowly dawning on them, going like, oh crap, this is not just the instruments malfunctioning, like something's actually happened here. But because it was 4 o'clock in the morning, I needed sleep. So I went back to sleep. But I've just kind of been tuning in, you know, here and there. And it's nice, you can scroll through the transcript and they've got a little section on there which is like milestones, mission milestones. And so you can go through there and you can click on, you know, key points of when interesting things happen. And I think always interesting things on Apollo 13, and you can kind of go back and listen to the audio. Like you can listen to it as it was now 50 years ago, or you can go and listen to any point that you want. If anyone wants to listen to when the problems start, it's 55 hours, 54 minutes into the mission. So there's a little red timer on there which tells you how long the mission's gone, so you can go and tune into that. But we've had a couple of comments come through about Apollo 13. This went a little bit wild when we were talking to Gavin. But someone who's DVWDF has said that you can actually download a simulation of the Apollo guidance computer, which I think is really cool. So it's https://svtsim.com/svtsim.moonjs/agc.html. But I imagine if you Google Apollo guidance simulation, it'll probably come up. So that sounds fun.
Yeah.
That feels like something people should definitely be getting up to.
Yeah. And of course, because it's running live now, you can also listen to the mission as it's unfolding now, and the mission's still in progress as it was 50 years ago today. So you can listen to the re-entry and all the cheers as they realise they managed to save 3 astronauts that they weren't at all sure they were. So I think we'll move now then from space flights back to astronomy, and we'll answer a question from @Blixbuller on Twitter, who asks about the ashen light of Venus, which some of you may not actually know what the ashen light of Venus is, but it's actually quite similar to Earthshine in that it's where the unlit portion of Venus sometimes appears to be lit as though it's a reflection from another body, which of course there is no other body nearby to Venus that would cast enough light onto it other than the sun. So does anybody want to go over kind of whether the ashen light of Venus actually is real for a start?
This is like lunar transient phenomenon. This is one of those things that various actually quite reliable people have said they've seen, but it's never been seen. So Patrick Moore was a big sort of collector of lunar transient. In fact, he's one of the people who claims to have seen the ashen light as well. But is it real? It's never been filmed. It's never been photographed.
Yeah, exactly. So I have more slides for this.
Oh, here we go. Slide time.
I know. So are you ready?
I'm looking.
Get on there. Hang on.
I'm waiting.
Let's move that.
It's gonna be good.
And then, okay, cool. Can you see that?
Oh,
yes.
look at that. There we go.
Yes. Right. Okay. So, Ashen Light of Venus should definitely be the name of an album or a song. I think it is, because I was Googling some images and stuff for this, and some songs were coming up. So, very good idea who I've decided to do that. So the Ashen Light of Venus is this thing that people claim that they've seen light coming from the dark side of Venus. But like Ralph said, it can't be reflected light. There's nothing anywhere nearby that's gonna have enough light for it to be able to reflect. So it's kind of got to be coming from the atmosphere or the ground or something itself. But it was first claimed to have been noted in 1643. Like it goes back basically to the dawn of telescopes. People have been claiming to be able to see it. Interestingly, quite a few people have said that they've seen it and that it's been like a reddish brown color, which is what I've got in the infographic on the left, and then the one on the right is a picture of Earthshine on the moon, where the moon reflects the light from the Earth. But yeah, it's an interesting one. If you were going to try and see it, the legend goes that if you're going to have a go, wait for Venus to be occulted by the moon, and so then when Venus is popping out from behind the moon, that's when you've got your best chance to see it, because you've got a very definite line where you can draw your eye to try and look for this definition between just the background stars and the actual full circle that is the sphere of planet Venus. Also when it's less than 30% illuminated, so you really want just a thin crescent of Venus to be visible, so that you can see as much of sort of the night side of Venus as you can. Orange and green filters might help you distinguish the difference, so people have said. But what is it? That's the question. What would be causing the dark side of Venus to not be actually truly dark? nobody knows really. Some people think maybe it's clouds are thinning, so then you can see the surface, but then that would only make sense if you were looking at Venus in the infrared, because you'd expect the ground to be bright in the infrared, but not in the optical, which is what we can see with our eyes. Some people have said also lightning strikes or like lightning within the clouds, but that would be way too faint for us to be able to see just, you know, from the Earth.
Definitely coverage as well.
Yeah. The most believable is oxygen in the atmosphere combining to form O2. So where you get UV photons photodissociating CO2 into, you know, carbon, two oxygen atoms, and then when the two oxygen atoms recombine, they emit like a green light. But that would be really faint. So it might be able to be seen by a giant telescope, but would it be able to be seen with your eyes? Probably not. And it can't be anything like aurora. Aurora? What kind of word is that?
Yeah,
Aurora.
Like that.
It can't be anything like the aurora.
Go with Aurora. It's late.
Aurora. Can't be anything like the aurora, because Venus doesn't have strong enough magnetic fields to have, you know, really powerful ones to be able to sort of see it from the Earth. So yeah, that's what the Ashen light of Venus is anyways. It's the light coming from the dark side of Venus, but who knows whether it's real or not. Don't know.
Yeah, well, for me, it's actually it's good that you raised the idea of transient lunar phenomenon, Paul, because I think it's kind of similar to that until which I should say, if people aren't familiar with that, that's kind of like flashes that seem to emerge on the dark side of the moon, and people aren't sure what they are, and there's lots of theories. It might be meteorite explosions or things like that, but no one's actually photographed them. And given that, you know, we've had there's a lot of amateurs that claim to see this. Same as with the Ashen light of Venus. We've had planetary imaging cameras around for amateur astronomers, good quality ones that are cheap for the last 10 years. People have had DSLRs for 20, 30 years. And we still don't have any pictures. So I'm still going with it being a kind of psychological trick. Until
I seem to remember we talked about TLPs on the podcast about 1 million years ago.
Yes, I think so.
We did. I can't remember. It was really early on.
It was a long time ago, yeah.
A long time ago. A little question from Stilo Puppy. Come up on the chat. And he said, for venereals, for Venus dwellers, would Earth be the brightest point of light in the sky, and would it be a double point of light? My guess would be yes, actually, because the albedo of Mercury would be lower than Earth's. And it would be a similar distance.
Pretty small.
And so Earth would reflect more, though it's not got as great albedo as Venus itself, because Venus, of course, the reflection is due to those acidic clouds, and the Earth is covered in a lot of cloud. Almost, you know, if you look at Earth, it's a lot of cloud, because you've got the polar caps and the seas as well. The seas reflect light, and then of course the moon. The moon is actually quite a dark object, one of the darkest objects in the sky. Curiously, it's only bright to us because it's really close to us. But I think from Venus, it would probably still be a reasonably bright object. So yes, you would get certainly with a small telescope or a pair of binoculars, you would definitely get a double effect. You would see the moon of Earth, but I would imagine Earth is probably the brightest object from Venus.
Right, well, I think we'll end it there. We've already overshot by 10 minutes. Apologies to those of you who didn't want an extra 10 minutes. But we'd like to thank Chris 1, Chris 2, Seth, who may be Chris 3, and Gavin for joining us, and for all of you for watching and taking part. We hope we didn't ramble on too much, but we'll be back on YouTube at the same time on the 27th of April. That's the 28th for our Antipodean friends, when we'll hopefully be a bit more structured as we record our May Astronomy live show.
And we shall now stand for the national anthem.
So yeah, thanks for coming, and thanks for sending in your questions. And I guess, I mean, we've still got so many questions that we have not answered, and we're so sorry that we never got round to them. But I guess we'll do this again, a live Q&A, if you guys liked it, and we'll get round to more of your questions in the shows as well.
Stay safe.
Hopefully we'll see you on the 27th of April. Thanks for watching. Thanks for taking part. Stay home. Stay 6 foot from everyone if you go out. And please, please stay safe.
Stay safe.
Bye.